In this lecture, we are going to discuss question 2A as an activity based question from chapter number 2, Geometry, Pythagoras Theorem. Those questions are from question bank provided by Maharashtra State Board. Look at the question 2A. Complete the following activities. 2 marks each activity we have. Write complete answer. Don't just fill the boxes. Look at the first question. From the given figure, triangle ABC, if AC equals to 12 centimeter. So here we have given AC is equals to 12 centimeter. Then AB equals to. We have given the activities of the form. From given figure, triangle ABC, we have an angle ABC that to be equals to 90 degree and angle ACB that is equals to we have given a 30 degree. Now next to it angle BAC is equals to, once we have sum of all angles of a given triangle that is equals to a 180 degree, so that here angle A we have to evaluate, that means an angle BAC. So plus we have angle B equals to 90 degree and angle C equals to we have given 130 degree, and that to be equals to now we are having a 180 degree. 90 plus 30 we are getting 120, 120 to be equals to 180. Now shift that 120 from LHS to RHS to find the value of an angle A. So 180 minus of 120, we are getting measures of an angle BAC. That means an angle A measures we have 60 degree. So the triangle ABC is 30, 60, 90 degree triangle. So in triangle ABC, by property of 30, 60, 90 degree triangle, we have the opposite side of 30 degree angle, that is the AB, is half of AC, and opposite side to 60 degree angle. Now we have an angle BAC means an angle A that is equals to 60 degree. So the opposite side of 60 degree angle, that is BC, is equals to we have root 3 by 2 times AC. So that we are getting the value of AB that is equals to half of, we have value of AC is 12 and value of BC is equals to root 3 by 2 times we have a 12. Next to it we have here the half of 12 means half times 12, we are getting a 6. Value of AB, now we have a 6. Look at the next one. Value of BC, again 2 ones are we have a 2 and 2 6 are we have a 12. Root 3 into 6 we are getting 6 times root 3. Look at the next one. Activity second is of the form. From given figure, in triangle ABC, AD is perpendicular on hypotenuse we have BC. Then we have to prove that AB square plus CD square that is equals to BD square plus AC square by completing the activity. So from the given figure, in triangle ABC by Pythagoras theorem, once the triangle ABC, in that triangle we have an angle A equals to, means the angle BAC equals to 90 degree. So we can use here Pythagoras theorem in triangle ABC. We are getting AC square is equal to AD square. That means here we have actually the triangle ADC. Look at this triangle, lowermost triangle. We have here AC be the hypotenuse. So AC square is equals to we have AD square plus we are getting CD square. Now once we are evaluating the value of AD square, we have AD square to be equals to, after all shifting CD square from RHS to LHS, we are getting AC square minus of CD square. Now in triangle ABD, look at the triangle ADB, that means this uppermost red shaded triangle. We have the hypotenuse becomes the AB. So AB square is equals to, we have a AD square plus BD square. So that I am writing AD square plus BD square. So once we shift the value BD square from RHS to LHS, we are getting here AD square is equals to AB square minus of BD square. Now let's have a look over equation number 1 and 2. Those two equations are having the same LHS, that is AD square AD square. so that we can equate their RHS are of the form AC square minus of, or at start we are having the RHS of equation 2, that is AB square minus of BD square, that is equals to we have AC square minus of CD square. So once we shift now BD square from LHS to RHS and CD square from RHS to LHS, minus will becomes plus BD square and minus CD square becomes now the plus CD square. So that we are getting AB square plus CD square, that is equals to we have AC square plus BD square. Now look at the third activity we have from the given figure in triangle ABC. If we have given angle ABC is to be 90 degree and angle CAB is equal to we have 30 degree, AC is equal to 14, then for finding the value of AB and BC, complete the following activity. So look at the triangle now ABC. In it we have an angle ABC equals to 90 degree, angle CAB equals to 30 degree. So the remaining angle we have a 60 degree, because sum of all angles of a triangle equals to 180 degree. So once we are taking angle BCA equals to 60 degree, then we may get 60 plus 30 plus 90, that is equals to 180 degree. So measures of an angle BCA is equals to we have a here 60 degree. So that given triangle ABC we have a 30, 60, 90 degree triangle. So we well known the opposite side to that of 30 degree angle, that is BC, is equals to we have half of the hypotenuse AC, and the opposite side actually to that of 60 degree angle, that is AB, equals to we have a root 3 by 2 times the hypotenuse AC. So that we have given here value of AC, that is the hypotenuse of given triangle ABC, is 14. So that we have BC to be equals to half of AC, means we have 14 now. After all simplifying we are getting here 2 1s becomes 2 and 2 7s are 14. So the value of BC is equals to 7, and root 3 by 2 times AC we have a 14. So 2 1s are 2, 2 7s are 14. So root 3 into 7, that means we have value of AB is 7 times root 3. Now the next activity we have activity 4 is of the form from the given NK equals to we have 90 degree and angle M equals to 45 degree. MK equals to we have 6. So let's try to put the value MK on the figure, that is 6. Then for finding the value of MK, actually here we have the MN, already MK we have given. So for finding the value of MN and the KN, complete the following activity. We have here now in triangle MNK, angle MNK equals to 90 degree, angle M equals to 45 degree. So the remaining angle is strictly equals to 45 degree. As per the triangle law, sum of all angles of a triangle equals to 180 degree. Once we are taking angle K equals to 45 degree, so 45 plus 90, we are getting 180 degree. So the measures of angle K equals to we have 45 degree. So the given triangle is 45, 45, 90 degree triangle. So that opposite side of 45 degree, first 45 degree angle, we are taking an angle M, which is the NK. So that we are writing NK to be equals to we have 1 upon root 2 times the hypotenuse, we have the MK. While other opposite side of 45 degree angle, we are choosing now angle K as a 45 degree, so which is MN. So that we are getting MN to be equals to 1 upon root 2 times the MK. Now we have given the MK value is 6. So MN equals to we have 1 upon root 2 times 6, while KN equals to 1 upon root 2 times, again we have MK value is 6. So that we are getting here 1 upon root 2 into 6. So we may write that the 6 as a 2 into 3, and we may have now the 2 as a root 2 into root 2 and 3 as it is, and 1 upon root 2 times, now we are getting 6 as a root 2 into 3. So 1 root 2 from numerator denominator getting cancelled. Root 2 into 3 we may write it as a 3 times root 2 and 3 times root 2. Actually our first side we have the MN. So let's try to fill up the first box by MN and next box by KN. We have to interchange the value. Once it is an isosceles right angle triangle, so we may have the Mn equals to the Nk, and both are to be equals to, we have 3 times root 2 and 3 times root 2 here. Now look at the activity number 5. We have a ladder 10 meter long reaches a window 8 meter above the ground. Find the distance of a foot of ladder from the base of wall. Complete the following activity. We have as shown in the figure. Suppose we have PR is the length of ladder, that is equals to, we have 10 meter. So PR be the ladder whose length we have given 10 meter. At P we have the window. At P we have the window. Q base of wall. Q be the base of wall. That means vertical wall we have the PQ. At R foot of ladder. Foot of ladder we have at R. So that we have now PQ equals to, as per the given 6 meter. That means height of window from, we can say, is ground level. We have the 6 meter as per the given. To evaluate the value of QR, we have in triangle now PQR, measures of angle PQR equals to 90 degree. So by using the Pythagoras theorem for a given right angle triangle PQR, we have a PQ square plus QR square, that to be equals to a PR square. Let's try to replace by value of them. As per the given, we have PR to be equals to 10 meter and PQ equals to, we have here a 6 meter. So that we are having here PQ equals to 6 meter. Now from equation 1, once we replace PR by 10 and PQ by 6, we are getting here. Look at once towards the given question. Actually here we have a 10 meter long window. That means we have a ladder is 10 meter long, reaches a window 8 meter above. So here actually we have height of window from ground, we have given the 8 meter. Keep in mind. That means we are having here the value of PQ is 8 meter and the length of ladder we have given, that is the 10 meter. So it is correct. PR value we have the 10. So that here we are getting the 8 meter be the value of PQ. So now it will be correct. 8 square, that means the PQ value we have 8, so that we are getting 8 square plus QR square, that is equals to PR value is 10, so that we are having here 10 square. Now once we shift the 8 square from RHS to LHS, so that plus 8 square becomes now the minus 8 square. We are getting QR square to be equals to 10 square minus of 8 square. 10 square is 100, 8 square is 64, so the QR square equals to 100 minus of 64. 100 minus of 64, we are having 36, so the QR square equals to 36. We have to evaluate the value of QR. We are getting a 6. Once we take the square root from both sides, QR squares are square root, we have the QR, and 36 are square root, we have a 6. Now look at the activity number 6. We have from the given figure in triangle ABC, if AD is perpendicular on BC, angle C equals to, we have given 45 degree. AC is equals to, we have 8 root 2. So let's have the figure 8 on figure. AC equals to, we have 8 root 2. BD equals to, we have 5. So the value of BD equals to, we have a 5. Then for finding the value of AD and the BC, this one is the BC, complete the following activity. So let's have a look over the activity. We have in triangle now ADC. Look at the triangle from the figure. We have red shaded triangle with the ADC. We have an angle ADC equals to 90 degree, angle C equals to 45 degree. This is given to us. So the measures of an angle DAC. So the remaining angle of a given triangle, that is the DAC, we have again the 45 degree. That is the remaining angle of a triangle ADC. Sum of all angles of a triangle we have 180 degree. Once we took measures of an angle DAC equals to 45 degree, so that we are getting 45 plus 45 plus 90 equals to 180 degree. So the measures of an angle DAC equals to 45 degree. So the given triangle ADC is of the form 45 45 90 degree triangle. So we well known the opposite side of 45 degree is 1 upon root 2 times the hypotenuse. So once we are choosing an angle C as a 45 degree whose opposite side we have the AD, so that we are getting AD to be equals to 1 upon root 2 times the hypotenuse is we have AC. And the same thing, once we are choosing an angle DAC equals to 45 degree, whose opposite side we have the CD, so that we are getting CD or might be the DC. As per the given, we have the DC be the name of opposite side. So DC to be equals to 1 upon root 2 times we have the hypotenuse as a AC. So the AD equals to 1 upon root 2 into value of AC as per the given we have 8 times root 2, and DC equals to again 1 upon root 2 into 8 times root 2. Now root 2 and root 2 from numerator denominator getting cancelled, so the value of AD we have 8, while same thing for the DC, root 2 and root 2 from numerator denominator getting cancelled, so DC equals to we have 8. Now once we are having AD value is equals to 8, now our target is to evaluate the value of BC. Since here point B, D and C are the collinear point, so the value of BC, overall BC becomes BD plus we have the DC. BD value we have given a 5 and BC value we are getting, DC value we are getting here 8, 5 plus 8 we have a 13, so the value of BC we have here 13. Look at the activity number 7 from question 2a. We have complete the following activity to find the length of hypotenuse of a right angle triangle if sides of right angle triangle are 9 cm and 12 cm. We have the activity. Now the triangle PQR we have is in the triangle PQR, angle PQR equals to 90 degree. So by using the Pythagoras theorem for a given right angle triangle PQR, we are getting PQ square plus QR square, that to be equals to we have PR square. Now the value of PQ we are assuming we have given as a 9 cm and value of QR, let us we are considering the 12 cm. So to evaluate the value of PR square, now we are having the PR square to be equals to value of PQ we have a 9, so that we are getting 9 square. Value of QR we have a 12, so that we are getting 12 square. Now we well known 9 square 9 nines are we have a 81, while 12 square 12 12s are we are getting 144. So 81 plus 144 we are getting 225. We have to evaluate here length of hypotenuse, that is the value of PR. So taking square root on both sides, PR squares are square root we have a PR, while 225 are square root we have a 15. So the length of hypotenuse of triangle PQR is we are having 15 centimeter. Now look at the activity number 8. From the given figure in triangle PQR, we have an angle QPR equals to 90 degree. PM is perpendicular on QR. PM equals to we have a 10, so that I am writing PM equals to we have a 10, and QM equals to we have a 8. QM is 8. For finding the value of QR, complete the following activity. So look at the activity we have in triangle PQR, angle QPR equals to 90 degree. PM is perpendicular on QR, so that by using a Pythagoras theorem in triangle, look at the triangle PMQ, this red shaded triangle we are having. We are getting PM square plus QM square, that to be equals to we have the PQ square, so that we can write now the PQ square to be equals to value of PM we have a 10, so 10 square, value of QM we have the 8, so 8 square. So the 10 square we have the 100 plus 8 square we have the 64. 100 plus 64 we are getting 164. So the value of PQ, taking square root on both sides, PQ squares are square root we have the PQ, and 164 are square root we are writing under square root 164. Now there are the three triangles. Look at the given triangle carefully. We have the triangle PQR. In it we have QPR is 90 degree, and now PM be the perpendicular on QR. QM value is 8, PM value we have a 10. So that the three triangles PQR, then PMQ and the PMR are similar, so that here we have the triangle that is QPR, which is similar to triangle QMP, which is similar to triangle we have a PMR. Now once we consider the triangle QMP, look at the figure, this blue shaded triangle QMP, which is similar to triangle PMR, this green shaded triangle, so that once the triangles are similar, their corresponding sides are in equal proportion. That means we are writing PM divided by RM, that to be equals to QM divided by PM. So once we are using the cross ratio test, means we are shifting the PM and the RM from RHS to LHS, LHS to RHS respectively, so that we are getting PM into PM becomes the PM square, that to be equals to we have RM into QM. So the value of PM we have given 10, so 10 square to be equals to RM as it is into QM value we have the 8, so into we are getting 8. So once we have here the 10 square becomes 100, that to be equals to we have RM into 8. Now our target is to find firstly the value of RM. So try to shift 8 from RHS to LHS. So that after all interchanging LHS and RHS, we are writing here RM to be equals to 100 multiply 8 becomes now the divisor. So 100 divided by 8. We have 4 2s are 8 and 25 4s are 100. So that the value of RM we have 25 divided by 2. So look at the triangle once the point Q, M and R are collinear, so that we are writing value of QR to be equals to QM plus MR. So here we have QR to be equals to QM plus MR. MR means the one of the same as that of the RM. So QM value as per the figure we have the 8 plus MR value we are getting here same as that of the RM, that is 25 divided by 2. Once we are doing here the cross multiplication, we are getting 8 2s becomes now is 16 and plus we have the 25 and divided by 2 1s we have a 2. 16 plus 25 we have 41 and divided by 2. So the value of QR we are getting 41 divided by 2. Now look at the activity number 9. We have find the diagonal of a rectangle whose length is 16 centimeter. So that here we are assuming length of the given rectangle is we have the LM, that is 16 centimeter. So once the pair of opposite sides of a rectangle are equal and parallel, so that we are getting TN value is also a 16 centimeter. And after that we have given area is 192 square centimeter. Complete the following activity. So as shown in the figure, quadrilateral LMNT is a rectangle. So area of rectangle we have length into breadth. So that the area of rectangle is equals to, we have given length of the rectangle is 16 centimeter. So 16 into we have the breadth. While area of rectangle we have 192, that is equals to we are getting 16 into the breadth. So for finding the value of breadth, we have to shift now the 16 from LHS to RHS. RHS to LHS actually, we are getting 192 divided by 16, that to be equals to breadth of the rectangle. So that the breadth of the rectangle we have 192 divided by 16, we are getting 12. So the breadth of the rectangle is 12. That means we are having the value of TL is 12 centimeter and which is same as that of the MN is equals to 12 centimeter. Look at the next step. We have also the angle TLM is equals to 90 degree. So once we consider the triangle TLM, that means this red shaded triangle, we are having in it angle TLM equals to 90 degree. So by using the Pythagoras theorem in it, we are getting TM square, that means the hypotenuse square. Hypotenuse is nothing but the diagonal of given rectangle, that is equals to we have TL square plus LM square. So that I am writing we have the LM square. Try to replace by their value. We have the value of TL is 12, so 12 square we are getting, and the LM is 16, so that we are getting 16 square. So that here we are having TM square to be equals to 12 square plus 16 square. Now TM square is equals to 12 square is 144, while 16 square we have 256. So 144 plus 256 we are getting 400. TM square equals to we have the 400. So after all taking the square root on both sides, we are getting TM value to be equals to 20. That means we can say that TM be the diagonal of given rectangle. So the diagonal of given rectangle we have 20 centimeter. Now look at the next and last activity from question 2a, activity number 10. In triangle LMN, L equals to 5, M equals to 13, N equals to 12. Then complete the activity to show that whether given triangle is a right angle triangle or not. We have given L, M, N are the opposite sides of an angle L, angle M and angle N respectively. Activity is of the form, in triangle LMN we have L equals to 5, M equals to 13 and N is equals to, we have given a 12. Now the square of L, that means L square equals to, we have 5 square is 25, while M square is equals to 13 square is 169, while N equals to, we have 12, so N square is equals to, we have 144. So that L square plus N square is equals to, we are getting 25 plus 144, that is equals to, we have 169. So that we have now the value of L square plus N square is equals to 169 and that is equals to the M square. So that here we are writing the N square plus N square, which is same as that of L square plus N square, because addition is always commutative. So that we are getting L square N square plus L square, that is equals to M square. So by converse of Pythagoras theorem we can say that triangle LMN is a right angle triangle once it satisfies the Pythagoras theorem. Square sum of any two sides equals to the square of third side. Hence here we have all 10 activities from question number 2A. Now here is in the question bank provided by the Maharashtra State Board. We have given directly the question number 3B. So during the next lecture we are going to discuss question 3B. Thank you.